Hi students, and welcome to part 3 of week 3's lecture for Exercise Science 118. And now on the lecture slides, we're starting with the lecture slide which is entitled The Biological Function of Lipids. So the important thing now just to get a few terminologies when we talk about lipids. On this slide here it says fatty acids, it says glycerides. The main thing to understand is when we talk about the biological function of lipids, we can talk about fatty acids, right? That's the things that we might eat. We might eat unsaturated fatty acids, or we might eat saturated fatty acids. We also talk about things called glycerides, because glycerides is how fat is stored within the body. So we said to you last week, we looked at how, when we use fat as an energy source, it's stored in our adipose tissue. Well, it's actually stored as what we call a triglyceride. And a triglyceride is a series of 3 either saturated or unsaturated fatty acids combined with a molecule called glyceride. So that's where the term glycerides comes from, glycerol. So the glycerol molecule combines with fatty acids to make a triglyceride. So it can be stored in the body in that way. Now some triglycerides or some glycerides like water, but most of them don't. So most of the time fats are actually afraid of water, if you like. So they're almost, we call them, that they're afraid of water, they don't like to interact. But there are certain glycerides that do actually have a polar aspect to it and combine well with water. But they're just things for you to understand about how the molecules actually work. Now the main role of lipids within a cell is storage energy, so we can use to make ATP, but also to function of cells, so function of cell walls and the building of cell walls, etc. So fat's really used for energy as well as for a building block for certain things as well. So obviously a really important, essential element for our body to consume. So you would have heard of essential fatty acids and non-essential fatty acids. We'll talk about them more in the weeks to come. But the main thing to understand is different definitions of lipids, and it can be a little bit complex, but we'll go through those step by step over the next sort of 8 to 10 slides. So we go to the next slide, it's entitled fatty acids. Let's talk about, first of all, not about a triglyceride, how it's stored. Let's look at the elements of what we call fatty acids. Now fatty acids are these long carbon chains which have the hydrogen attached to them. So you can see there in these molecules, the first one there is stearic acid. So stearic acid has 18 carbons to it. Whereas, remember before we looked at glucose only has 6 carbons. So straight away you can see in these fatty acids, they have a lot more energy bonds to break down, so a lot more energy within them. Right, so these fatty acids, the saturated ones have all the bonds are taken up, so there's no bonds left over. All the, carbon has an ability to make 4 bonds, so in theory, in most of these aspects here, carbon's either combined to 1 or 2 other carbons, and it's got 2 hydrogens attached to it. So it's, like I said, it's fully bonded, we don't want to have any more bonds with it. So that's why it's called saturated. The reason why it's called saturated is that carbon is saturated in the amount of bonds it can form. So there's no bonds left over. So the example of that is butter. Anything like that is what we call a fatty acid. So a lot of, when we eat meat, a lot of those are things what we call fatty acids. Whereas on the next molecule down from that, we have a thing called oleic acid, which is what's called an unsaturated fatty acid. An unsaturated in this situation is mono. Mono means there's one double bond. So you can see this molecule here, it's actually shaped very different than the fatty acid, than the saturated one. Unsaturated fatty acid means that the carbon molecule isn't completely saturated in relation to its bonds it could actually mix with hydrogen. So mainly what it means is they have double bonds. That's what unsaturated fatty acids have. And unsaturated fatty acids having these bonds, also if you look at the structure of that, it actually has a bit of a kink in it. So kink in it means at room temperature, they're more oils, liquids, whereas the straight saturated fatty acid is more solid at room temperature. So that's a good way to try to recognise the difference between the two. So there's the two there I've just shown you, that's why butter is a solid at room temperature, but olive oil isn't, because it's an unsaturated fatty acid and it's structured very differently as well. Alright. Now keep in mind too, these fatty acids also at the end of them have what's called this carboxyl group. So COOH group. And that's what we call a weak organic acid, all right? And it's also known as a proton donor, but I don't want to get into the chemistry yet. It's just good to know they have a carboxyl group at the end of it too. And like I said, the unsaturated fatty acid has the double bond, and because the double bond has this little kink in it, and that means that the fatty acids can't stack on top of each other as much. Therefore, they have lower, what they call molecular attractions, they have lower melting points. So the unsaturated fatty acids have lower melting points and therefore they're liquid at room temperature, and that's because you can't stack them on top of each other like you can with the saturated fatty acids. So again, just good to know the differences between the two. Now, even further, if we look at the next slide, which has, again, it looks at the structure of saturated and unsaturated fatty acids. This one has, at the bottom of it, has what's called a polyunsaturated fatty acid. I'll go into a little bit more in the next slide. But polyunsaturated fatty acid just means 2 or more double bonds. So on this particular slide here, we can see there's actually 2 double bonds in this particular saturated fatty acid. So it's got carbons, it's got hydrogen, it's got the carboxyl group at the end of it too, which I'm just circling now, but it's got these double bonds in it, and that means it's unsaturated, but also because it's got more than one, it's called polyunsaturated. Right, so you would have heard of terms of something as polyunsaturated as opposed to something that's just unsaturated. Right, so that's the difference between the two. Now, if we go to the next slide, we now look at particular fats which are called biologically important fats. Now, in theory, they're all biologically important, but they're things you might have heard of before. And they're called omega-3 and they're called omega-6. And they're actually quite popular for good health. And there's a number of reasons why, but a lot of the fishes and things like fish oils and so forth, different sort of like soybeans, canola oils and things like that, they're known to have what's called these omega-3 and omega-6s. Now, the interesting thing about these is if we look at the way they're structured, let's go first of all, let's look at omega-3 unsaturated fatty acid at the top left-hand corner, which is entitled DHA. And you can see the number there, it says 22, 6, and N equals 3. Now what that means is this. The 22 means the amount of carbons is 22. The 6 just means it's got 6 double bonds, and the N means the first double bond is 3 carbons from the end of the fatty acid. So that's what those numbers 22, 6 and 3 mean. Whereas EPA, which is again to the right of that, and I'm not even going to try to pronounce EPA in its long, let's just keep it as EPA because there's no way I'm getting that one right. But again, with this one here, it's got 20, so it's got, I'm looking now at the number 25 and N equals 3. So it's got 20 carbons, it's got 5 double bonds within that unsaturated fatty acid, and the first double bond starts at N equals 3. And then every 3 from then on in, every third carbon has that double bond, and that's where the omega-3 comes from. Whereas if we go down to the bottom right-hand corner, we've got linoleic acid. Now that again, in the numerical bracket next to it, it's got the words, it's got the numbers 18, 2, and N equals 6. That means it's got 18 carbons, it's got 2 double bonds, and the first double bond starts at 6 carbons from the end. And that's where the omega-6 comes from, right? So therefore, every 6th carbon from then on in, it looks at that. In this situation here, you've got N equals 6, that's when the first carbon comes from, and then a few carbons later, it's got another double bond there. So it's only 2 double bonds, but the first double bond starts at 6 carbons from the end of the fatty acid. Right, and again too, you're not going to be asked to reproduce that in the exam, but you will need to know the difference between an unsaturated fatty acid and a saturated fatty acid. So again, just to go through it, saturated means there's no double bonds, carbon is completely saturated in relation to hydrogen, whereas in the unsaturated fatty acid, there are double bonds, which means that carbon isn't saturated in relation to its hydrogen bonds. And therefore, they have more of a kink to it, they can't be stacked on top of one another, and therefore, room temperature, they're oils because they have a lower melting point in comparison to the saturated fatty acids. And then more particular, we have these different types of unsaturated fatty acids, which are omega-3 and omega-6, and they have multiple double bonds, and therefore they're polyunsaturated fatty acids as well. So again too, like I said, just to go through them step by step, it's important to understand. Now the next slide we've got at the top, it's entitled glyceride and non-glyceride lipids. Now it's got here 2 types, there's neutral and there's what they call phosphoglycerides. Really, okay, to make it as simple as possible, we want to focus for you guys on knowing the triglyceride. And the triglyceride, which again we'll go about, I'll say later a lot, but we will look at this more when we look at the functions of fat metabolism and carbohydrate metabolism within the body in weeks 5 and 6. But the main thing to understand here is triglycerides, meaning 3 fatty acids, and they can be a combination of being saturated or unsaturated. So you've got 3 different fatty acids, and they'll combine with a molecule called glycerol. And they are normally called what they call neutral glycerides, meaning they don't like water. So they don't have what they call polar heads to them. So they're what we call neutral glycerides. But you can also have these triglycerides which have like a phosphate group on them, and that can be a more polar molecule, and therefore they don't mind being near water. So there can be two different types. Triglycerides that like water and those that don't. The majority of the ones that we deal with in the human body don't like water, and that's why it's really hard to get them into the muscle cell and to get them into the mitochondrial matrix to actually metabolize them, because it's a very watery liquid form and they don't like to be attached to water. Then you've got these other ones called non-glyceride lipids, and it's got sphingolipid, but we don't really deal a lot with that. So again, I'm not going to focus too much on that one too. They're not things you're going to get in the exam. The main thing is the top one, look at neutral and phosphoglycerides. The phosphoglyceride has a phosphate molecule attached to what they call a phosphoryl group, and it's more polar. So it likes water, where the neutral glyceride doesn't. All right, now, if we talk about triglycerides, this is our first step in understanding triglycerides, but we do talk about this a lot later as well. So this is just step number one, so not to get too overwhelmed by the information. But here is an example here. So we've got the lecture slide now entitled triglycerides. Here is an example of, you've got a glycerol backbone, which is on the left-hand side here, and then you've got your three fatty acids. In this situation here, you've got a saturated one, another saturated one, and fatty acid number 2, and fatty acid number 3 is an unsaturated fatty acid. So those three fatty acids will combine to a glycerol molecule, and that will make a triglyceride. Now, just like we had with glucose molecules and carbohydrates, when we make a triglyceride, this is called the process of dehydration synthesis, right? It's also, I'm not trying to get too tricky, but can also be referred to as esterification, okay? Because these are also called esters as well, so not to confuse you, but if you hear the term esterification, it's the making or the building of a triglyceride, right? So this would happen where our body takes in maybe oils or meat, or whatever it might be, and we digest it, and then we want to store it in our adipose tissue, so it gets stored as a triglyceride, and that's done through the process of dehydration synthesis. But on the flip side, if we want to go for a long walk and our body wants to make ATP and it wants to use fat to make ATP, we can now break down a triglyceride, which is over here in the adipose tissue. We can break it down through the process of hydrolysis, but because it's to do with lipids, we call this lipolysis. So lipolysis is the breaking down of a triglyceride, so we can use the energy, right, to make ATP, which we talk about later. But again, too, this slide here is just showing you how a triglyceride is formed and how it's broken down. And it is important for you to understand that process, all right, that we don't just store fat as saturated or unsaturated, we actually store it as a triglyceride. All right, the next slide here just looks at the amount of energy that we have from triglycerides and carbohydrate. So really, like I said to you before, if you look at this slide here, you can go through and look at it on like yourselves, but the main thing you can see is if we starved ourselves completely, we would have enough energy, right, in the adipose tissue for almost sort of 32 days, as long as we had water. But I said to you before, in relation to carbohydrate, we have enough energy for maybe a couple of hours max. So the main thing to look at here is that fat gives us a huge amount of energy. We can't break it down quickly, and we can't use it for high intensity exercise, but we can use it for aerobic activity, which is lower, which is around sort of 30 or 40% of your max or less, depending on your fitness status. But again, too, the main point there is we've got a lot of energy through fat that we can actually use. But we do need a readily supply of carbohydrate in order to burn that fat, which I'll talk about later as well. And that's when we say that energy is burned in the flame of carbohydrate. So if you understand your sort of chemistry of the body quite well, you understand that we actually need carbohydrate to make a certain substance so we can burn fat as much as we can. So it's a combination of both. But the point of this slide is to look at the amount of energy in fat compared to carbohydrate. All right, the last thing we look at here in relation to lipids is looking at what we call complex lipids. Now, complex lipids, you might have heard of things like high density lipids and low density lipids. So when you get your cholesterol tested, it will give you two numbers. It will give you high density lipids and low density lipids. And your HDLs are like your good cholesterol. They're like your Pac-Man that come away in scavengers, eat away at the low density lipids. The LDL, the low density lipids, is the number you don't want to have too high of because they tend to accumulate on the wall of certain arteries and so forth, and they can clog up and cause a problem with atherosclerosis and the event of heart attacks and so forth after that. But the main thing here is the complexity of lipids is the more protein the lipids has, the better it is for you. So high density lipids have the most protein out of these lipids, complex lipids, than any others. But the main two that we deal with are what's called high density lipids and low density lipids. And if we go to that next slide, which is our last slide on fat, on lipids, is they're your four main complex lipids that we talk about within the body. But the main ones that we really focus on is on the right-hand side, which are LDLs, low density lipids, and high density lipids. And like I said, the high density lipids have the most amount of protein, and therefore they're healthier for you than the low density lipids. But it's good to know too that when you get your cholesterol taken, it's good to keep an eye on those two numbers, so you know that we should be having a good ratio of the two, but the higher the HDLs, the better for us as well. Alright, so that's it for the lecture on fatty acids or on lipids. The last one for this week will be on amino acids and proteins.